Hello everyone. The first paragraph in chapter 3 is going to be about something called f-angles and something called z-angles. So I'm going to start by showing what they are, how we can use them, and finally I will give an example of, again, how they are used. So what are f-angles, what are z-angles, where do they come up? They come up whenever we have two parallel lines and any line crossing them. And you might already notice, or maybe it's a bit too abstract at this point, but we can kind of make an F and a Z in this. Here I have my Z, or the other way around, little strange Z, and I can also make an F. And again, also the other way around. Okay, but what does that mean, F and Z angles? What it means is if I have a Z like this, two parallel lines and one extra line, extra line in between, then these angles inside my Z are equal, and they will always be. So if I mark these for a moment, if I say this is A, 1, 2, 3, 4, B, 1, 2, 3, 4, then from the Z angle I just made, I see that A3 is the same as B1. So I can say angle A3 equals angle B1 as a Z angle. I can also use my F angles, for instance here, and then it is about this angle and this angle, the ones underneath my F basically. So A3 is the same as B3. Let me also write that down. And this time as an F angle. So what this does, it helps us compare angles that are actually part of a different point. Before we could only compare them if they were in the same point with the opposite angles, the straight line, straight angle rather, full turn, etc. Now we can compare them if they're in different angles. And that's a very interesting property whenever we have parallel lines. The interesting thing is that it actually also works the other way around. If I have two lines, I don't know if they're parallel, but I know that these two angles are the same. Let's call these L and M. Then because these two are the same and they form an F angle, I can say that they are in fact parallel because the F angle works. Similarly, if I know that these two are the same, the one at L and the one at M, then because of the Z angle, I can again say that L and M are parallel. So this rule works both ways around. If we have parallel lines, we can use it to compare angles. If we know some angles, then we can use the Z and F angle to see whether lines are parallel. So that is very convenient. Now let's put this to the test in a parallelogram. We've got lots of parallel lines there, so we should be able to use these rules very nicely. So suppose I have my parallelogram A, B, C, D. And you might remember that opposite angles in a parallelogram are equal. These as well, of course. And now we have the material to prove this. So suppose we want to prove these two in this case. The other ones are going to work the same way. I can't make any Z's just yet. I'm still missing something. So what I'm going to do is I'm going to extend this one a little bit. And now I can make a Z. So I can say that angle C is the same as angle B2 because of Z angles. But I can also, that's a little thin, can also create an F here. Starts to get a little bit messy, but that means that this angle and this angle has to be the same. So I also know from F angles that angle B2 is angle A from F angles. So we can conclude from these two that angle C is angle A. So that's just already a first example of a proof, and what a proof is and what that's supposed to look like. We're going to see more about that in the next paragraph. But this is just a small example of what we can do with our Z angles and with our F angles. And with that, you can start practicing with the exercises.